Hello everyone, my name is Rohit Singhal and we were discussing about the topic redox reactions. Till now we have discussed about certain rules to calculate the oxidation number of any element in the compound. Okay. Using those rules we will now see how we can calculate the oxidation state. But just before doing that, one thing to keep in mind that the representation of oxidation number. Okay. The representation of the oxidation number is done by the Stock notation. What the Stock notation is, that means the oxidation number is written in Roman numbers. Okay. For example, if I am saying SnCl2, so I will say Sn in 2 oxidation number. Okay. For example, if I am saying FeCl3, Fe in plus 3 oxidation number, right. So, just this thing, this for example, I am using AlCl3. So, Al is in plus 3 oxidation number. Okay. Just you have to do the, and generally how it is written after the metal it has written. Okay. So, normally you can also write Sn2 Cl2. Okay. This is also thing, that means the oxidation number of the oxidation number is written in the Roman numbers for the metals. Okay. This is just the representation of the oxidation number, one of the things left. This is Stock notation. Okay. Now, I will discuss briefly about how to calculate the oxidation number of a few molecules, and that you can exercise later of your own. One of the examples I have discussed is CO3 2 minus. Okay. Now, you know oxygen is minus 2. So, 3 oxygen carrying a minus 2. Let us say I have asked the oxidation number of carbon I have to calculate. So, 3 oxygen carrying a minus 2 charge. Let us suppose carbon has an oxidation number of x. Now, the sum of both the oxidation number will be what? Will be equal to the charge on the ion minus 2. Okay. So, you can just now simplify it, get x minus 6 is equals to minus 2, x is equals to plus 4. That means, the oxidation number of carbon in carbonate is plus 4. Sulphate, sulfur you have to calculate. Okay. Oxygen is minus 2, 4 into minus 2, x for sulfur, algebraic sum will be equal to what? Charge. Charge is what? Minus 2. Again solving the equation, x is equals to x minus 8 is equals to minus 2, x is equals to plus 6. That means, sulfur is present in plus 6 oxidation number. Okay. Now, okay, one of the cases where chlorine is present in positive oxidation number with oxygen. Okay. So, you know oxygen carries minus 2 charge, minus 2 for oxygen. How many oxygen? 3. Total charge is 0. For chlorine, let us say x. So, x has a plus 6 oxidation number. Okay. Generally, it exists in minus charge. So, let us say, let us write the right formula, ClO3 minus, it exists at like this. So, minus 1. So, it will have an x minus 6 equals to minus 1. So, x equals to plus 5 oxidation number. So, chlorine is present in plus 5 oxidation number. Okay. This is how you can calculate the oxidation number of any element in any compound. Okay. This I briefly discussed about this calculation of oxidation number. This in detail calculation of oxidation number for various compounds or various elements. This you will discuss later on in class, later on in further classes. Or I can discuss a few examples also, but let us for now if I have started. So, let us say 1 or 2 more examples, starting with an example. Let us say let us take a molecule, let us take a compound that does not have only 2 atoms, it have 3 atoms, right. And you are asked to calculate the oxidation number of sulfur. Sulfur oxidation number we need to calculate. Okay. Now, how we need to calculate it? To calculate the oxidation number of sulfur, what we need? We need the oxidation number of sodium and oxygen. We know the sodium belongs to group 1. It has a oxidation number of +1. That means 2 sodium are carrying a +1 and +1 oxidation number respectively, right. For sulfur we will write X. Okay. For oxygen having a -2, right. Oxides these are, if it is not oxide, that you will get to know, or they will tell you that it is not an oxide. Okay. In any general case, first you will try that oxygen has an -2 oxidation number. Okay. These 4 oxygen are there, the 4 oxygen is -2. How much charge is there on the entire compound? It is 0. Now, let us solve the algebraic equation. 2 plus x minus 8 0, x minus 6 equal to 0, x is equals to plus 6. Okay. Now, if one of the another examples, if I say calcium sulfate, can you calculate oxidation number of sulfur only? For calcium it is +2, for sulfur it is x, for oxygen it is, so +2 plus x minus 8 is equal to 0, x minus 6 is equal to 0. So, in case of calcium sulfate also, sulfur has a oxidation state of +6. Just remember this thing, ki this sulfur belongs to what? Sulfur belongs to group 16, right. That means sulfur can have a maximum oxidation state of 16 minus 10, that is 6. So, this 6 oxidation state of sulfur is possible, okay, because the oxidation state of group 16, the maximum oxidation state of group 16 can be 6. So, the sulfur is in +6 oxidation state. Now, just taking one of the examples where 2 sulfurs are present, let us say Na2 S2O3. Okay. Now, what is this case? And someone asks you to oxidation number of sulfur. Now, there are 2 sulfur. You must be wondering that which sulfur oxidation state you need to calculate. Okay. And if I do this thing, okay, if I just do this thing, that sodium is +1, okay, sulfur is, let us say S, for sulfur it is X, for sulfur we assume it is X. How many sulfur are there? 2 sulfur. So, that means 2x, for oxygen -2, 0, 2 plus 2x minus 6 equals to 0, 2x minus 4 equals to 0, 2x is equals to 4, x is equals to +2. Okay. The oxidation number of sulfur is +2. Now, you must be wondering that +2, how does it +2 means that whether it is for one sulfur is +1, another sulfur is +1, you do not need to worry about these at this level. You just see this is an for one sulfur, okay, and this is called as average oxidation number. Okay. This is called an average oxidation number. In general, what it is happening in general, or let us say if we see that 2 sulfurs are having a +4 charge, right, 2 sulfur are having a +4 charge. It is possible that both have +2 and +2. It is possible that both have one has +1, one has +3, okay, or any other. That that we can only know when we know the structure, that what is the structure of Na2H2O3. Okay. But if you will be asked to calculate the oxidation number, you will not be asked to calculate the oxidation number for different sulfur. You will be asked to calculate the average oxidation number. So, the average oxidation number for Na2H2O3 is plus 2. Okay. Okay. So, this I have discussed a few examples with you, that how we will calculate the oxidation number of any element in the compound. Okay. You just see which metal is there, you know the some general oxidation number of oxide, halide. Okay. This you know, hydrogen you know, sodium you know, group 1, group 2, and then central atom oxidation number you will be asked to calculate. This is how you will calculate. If there are more than one atom, or one atom of which oxidation number is asked you to calculate, then you use a simple thing, you use 2x or 3x or 4x, and this will be determined as average oxidation number. No separate oxidation number will someone ask you to calculate, and average oxidation number can be calculated. Okay. Now, just moving towards one of the examples given in your NCERT textbook is problem 7.4. It is saying this, an equation is given 2Cu2O, this solid, plus copper sulphide solid, and it is giving 6 copper solid plus SO2. Justify that the reaction is a redox reaction, and you have to identify whether which species is getting reduced, which species is getting oxidized, okay, and which acts as an oxidant and which acts as an reductant. Okay. Okay, now let us calculate the charge on let us see this equation on the terms of charge transfer. Okay. So, charge transfer, if I see, oxygen has a charge of -2, we know. Okay. So, copper having a charge of what? +2, but 2 copper having a charge of +2. So, 1 copper has a charge of +1, right. To balance this out, to have this neutral, this 2 copper will have a -2 charge, or we can say, let us say calculate, which I have shown you, that is 2x minus 2 equal to 0. So, x is equals to 1. The oxidation state of copper is +1. Similar with the case of sulphide also, it is +1. Copper present in unfree state, so it is 0. In case of SO2 gas, this is SO2 is gas. So, you know x for oxygen it is 2 minus 2 0. So, x is equals to +4. So, the oxidation number of sulfur in SO2 is +4. Now, you know ki you have calculated the oxidation number of copper and sulfur in both reactants and products. Okay. Now, we will discuss that which element or which molecule is getting oxidized, which is getting reduced, or whether it is a redox reaction or not. How we will know whether it is redox reaction or not? If both the reduction and oxidation is getting take place. Now, copper, if you see, copper is getting from +1 to 0. Okay. The copper is what? Gain of electrons. Okay. Sulfur is -2 here. Here also, if you say copper is gaining electron. So, copper gain of electron, +1 oxidation number to 0, that means reduction. Okay. In case of sulfur, loss of sulfur is going from -2 to +4, it means loss of electrons, or you can say oxidation number is increasing. Okay. So, that means it is an oxidation, and both reduction and oxidation reactions are taking place in this. That means, it is a redox reaction. Okay. This is a redox reaction because there is a transfer of electrons and one species getting oxidized, one species getting reduced. Okay. So, oxidation because copper and which species is getting oxidized? Copper is getting reduced, copper is getting reduced, copper has been reduced and sulfur has been oxidized. Okay. So, this has been asked which species is getting oxidized? Copper has been reduced going from +1 oxidation number to 0, that means decrease in oxidation number. So, you can also say that decrease in oxidation number is what? Reduction, because decrease in oxidation number is nothing but the gain of electrons, whereas sulfur has been oxidized, it goes -2 to +4, increase in oxidation number. That means, you can also describe the oxidation and reduction process in terms of what? Oxidation number. If oxidation number is getting increased, it is oxidation. If oxidation number is getting decreased, it is reduction. Okay. Now, the next thing is asked, what is oxidant and what is reductant? Oxidant and reductant. Okay. Oxidant and reductant is nothing but oxidant is called oxidizing agent, it is nothing but oxidizing agent. Reductant is nothing but reducing agent. Okay. Now, see, now which is getting oxidized? Sulfur is getting oxidized, right. What is responsible for sulfur to get oxidized? Which is helping sulfur to get oxidized? Which is taking electron? Copper 1 plus. What is taking electron? Copper 1 plus is taking electron. That means, copper 1, not copper. Copper 1 is an oxidizing agent because copper 1 is taking electron from sulfur. Take copper 1 is taking electron from S2 minus. Okay. Copper 1, not copper. Reducing agent. Now, we will see which is what giving electrons. Now, we know reducing agent is nothing but with the element which has been oxidized, which has been reduced. Okay. Oxidizing agent has been copper 1 because copper has been reduced. Okay. Now, for case of sulfur, reducing agent means we have to see the term which has been oxidized. Sulfur is oxidized, okay. But sulfur is not oxidized, S2 minus has been oxidized, S2 minus copper 1, that means the reducing agent is S2 minus. Okay. So, just see ki oxidation which is happening, copper 1 plus is getting reduced to copper 0, sulfur is getting oxidized from -2 to +4. Okay. Now, which is an oxidant or reductant? Means oxidizing agent and reducing agent. Oxidizing agent, that means which is taking electron, which is taking electron? Copper 1 is taking electron, not copper, copper 1 is taking electron. What is reducing agent? That is giving electrons. What is giving electrons? S2 minus is giving electron. Sulfur of the copper sulfate, sulfide of copper sulfate is giving electrons, that means it is an reducing agent. In the next classes, now we will discuss about the types of redox reactions. We have certain a number of redox reactions: decomposition, disproportionation, displacement, double displacement. Briefly, you might have studied about this type of reaction in class 10th. Now, we will discuss about in terms of redox reaction in the later classes. Thank you so much.